Next example is going to be a crank slider. Once again, we'll need to make sure we number all the links so we know which links we're talking about. So we have 4 links, and so draw the circle diagram of the graph, and we will have 1, 2, 3, 4 points on that circle diagram. Okay. Now there are 4 lower pairs in this particular mechanism in this crank slider. We have instant center 1, 2 at that pin. We have instant center 2, 3 at that pin, and we have instant center 3, 4 at that pin. Then we have instant center 1, 4, which is the instant center between the sliding link and ground, and that one is, we write 1, 4 at infinity. And we can think of that as a point either infinitely far away in the vertical direction or infinitely far in the down direction or up direction, either one. And we'll see that it doesn't matter which way we think of that. Okay, and so we've got 1, 2, 2, 3, 3, 4, and 1, 4. Okay, and this is just as good an instant center as any of these other ones. Just we can't draw it on the page, but this indicates exactly where it is in some sense. That we know exactly its direction and we know how far away it is. And so we have a point that's located there for that one. So we know where 1, 4 is. All right, so we're going to find instant center 1, 3. So I'm going to mark that that's what I'm going to look for. And so 1, 3, I'll have a triangle like this that I'll write down as 1, 2, 3. And I'll have a triangle like this that I can write down as 1, 3, 4 or 1, 4, 3. Either one is fine. They mean the same thing. The points I already know are the ones that are solid there. So it's 1, 2 and 2, 3. So those are the instant centers I already have in this line. And the instant centers I already have in this one are 1, 4 and 3, 4. So once again, we write down our plan looking at the circle diagram going from left to right, and then we work the plan going from right to left. So this line right here says I'm going to connect the dots between 1, 2, and 2, 3, right there. And that will give me my instant center line 1, 2, 3. Then this next one, I have 1, 4, and 3, 4. 1, 4 is along this line, and 3, 4 is right there. So in fact, this line that I've drawn actually is instant center line 1, 3, 4, and I just need to extend that line there, and then I can extend this one where those two intersect is going to be instant center 1, 3. All right, so that means I now know where instant center 1, 3 is. I can do a similar thing for 2, 4. I want to find 2, 4. I've got a triangle right here that's 2, 3, 4, and a triangle right here that's 1, 2, 4. Okay, so I can find, I already have 2, 3, and 3, 4 from this lower triangle, and from the upper triangle I have 1, 2, and 1, 4. All right, so that means I need to connect the dots between 1, 4 and 1, 2. Now, this is where you really have to think about this 1, 4 being off at infinity, okay? Because 1, 4 is not at the end of this arrow. It's infinitely far in that direction. But if I thought about the line as if it was right there, then I'd have this line. Okay, so that's not the one I want, but I think about as that point moves down where my line's going to go, and basically that line's going to keep rotating as I point to a point further and further away, and eventually, you know, unless this line becomes parallel like that, the lines are going to intersect before I get to infinity. So parallel lines intersect at infinity. Sounds like some kind of joke, but it's how this method works. And so what I do is I say 1, 4 at infinity in that direction. And so this line right here is the line 1, 2, 4 that I want to use there. I also need to use 2, 3, and 3, 4. So 2, 3, and 3, 4 are fairly ordinary points. And so I can just connect the dots, and I can extend those two lines until they intersect. Okay. And so that'll give me instant center 2, 4. Now that I've found it, just a comment on what they mean. 1, 3, that's a point that acts like a pin joint at this instance between ground and link 3. So the way you can think of it is at this instant in time, link 3 is rotating about that point. So maybe this point is going that way, and this point is going that way. And so we can imagine link 2 has to be rotating clockwise, okay, and then link 3, it's rotating about this point in that direction, which is counterclockwise, and of course link 4 is just sliding along. Okay, so instant center 1, 3 helps me visualize the motion of link 3. Now, 2, 4 is kind of interesting as well, because this is a point on link 2 that has the same velocity as a point on link 4. Now, link 4 is a slider, which means this point and this point have the same velocity. Every point on the block has the same velocity. And if I imagine stapling a sheet of paper to this thing and extending it, this point on link 4 also has the same velocity. So the way to think of this is this right here is a point on link 2 that has the same velocity as link 4. And so if I were to extend link 2 up here, I could find the velocity of every point on link 4 just by measuring the velocity of that point right there, which is kind of cool. All right.